Hi everyone, welcome to today's webinar on resource road design using LiDAR data. My name is Erin. I'm going to be your host for today's webinar. So today we are going to be talking about sort of all resource roads. Now this includes a wide variety. It could be a forestry road, a mining road, you may be an access road, a haul road, possibly a wind farm road, or any other kind of sort of rural road. But today we're going to be doing something a little bit different. Most of our webinars have historically focused on steep, rugged, mountainous terrain, where obviously we love to talk about road design, but today we're going to be focusing on a flatland example, where in some industries, for example, forestry, there's been a real historical reluctance to actually design roads as opposed to just using GIS and then flagging a line. So today we're going to be going through a streamlined workflow, talking about how you can leverage some of the different efficiency tools inside of RoadEng to look at drainage considerations, to design alignments, to get volume estimates, and to create highly usable construction documentation. And there is a lot of advantages of working with LiDAR data in flat terrain to design roads. This could be, reducing the time required to plan your project, reducing uncertainty in what that plan is, and then of course our favorites, being able to choose better road locations that are better considering drainage, and of course, being able to better communicate those plans more effectively to your road builder. So we're going to, over the next 45 minutes, step through a workflow in the software. But we encourage you as we go through this workflow, sort of as usual, if you've got any questions about what we're talking about, or even if it's a little bit off topic, feel free to type them in our chat. You can open up your GoToWebinar panel and there should be an option in there to ask questions. So type them in. All of our question askers do remain anonymous throughout the webinar. So I wanted to highlight, before I pass it over to my colleague Matt, one of the questions that we pretty much always get, which is kind of, what are we using in terms of the software, so the version, as well as the specifications of the computer that we're going to demonstrate. So I thought I'd include this in the upfront. So today we're going to be using our full product, which is our RoadEng with Softtree Optimal software. It's version 11, so that's our most recently launched version this past spring. And with that, there are two modules. So you're going to see us use two different parts of the software. The first part is the terrain module. That's where we're going to build our surface, import our LiDAR data, do our thinning, and work with some of the hydrology tools, as well as our landscape level path exploration tool. From there, we'll head over into the location module, and this is sort of that detailed road design part of the software, but hopefully you'll see in today's workflow, it's not that scary. It's got a lot of tools that are going to kind of help streamline that process for you with some automation. In terms of the computer being used for the core part of the demonstration, it's a 16 gigabyte of RAM computer. As you'll see, as you work with increasingly large LiDAR data sets, the key piece kind of from a computer perspective is the RAM. So this one that we're working with today, 16 gigs of RAM, it's got a newer i7 processor. In terms of what our minimum recommendation when working with LiDAR data and when working with some of these efficiency tools like Path Explorer or the Hydrology toolkit, we'd be kind of recommending probably 8 gigs of RAM as your sort of minimum recommendation. So a standard business grade laptop, you don't need anything too fancy, but that's what we're working with from the specification side. Finally, I did want to highlight a couple of the key tools that we're going to be using to discuss this resource road design in flatter terrain. To start, today's LiDAR data is in DEM format. And when you're working with LiDAR data, especially really large LiDAR data sets, it's really important to be able to control how much data you have. Of course, when you're working with really large tiles, you may not need all of the information in there. You may have a polygon of interest, or you may just have too much data initially, and you need to control the resolution of it. So when working with DEM LiDAR data, there's actually a different tool that we'd recommend. So we're going to highlight that today. That's the simplify/smooth tool. Of course, we're not using the smooth part, we're using the simplify. So we'll talk a little bit about that, as well as where you can get to thinning tools if you're working with LiDAR in, say, an LAS or LAZ format. From there, we're going to focus in on our streams and ponds tool. That's part of our hydrology toolkit. Leverage this for determining the location of streams and ponds. Again, drainage in flatter terrain has so much importance. So we're going to be using that tool to help shape our road design. Finally, we toyed with the idea of not including this one, but at the end of the day, it adds so much efficiency. We've decided just to throw it back into the plan. So we're going to be using Path Explorer AI to help us figure out the best location for our road design. So this is a tool within our terrain module that can help find optimized road locations, sort of given a start and an endpoint. From there, we'll pivot over into the location module, leverage again some of those efficiency tools. Polyine to alignment is one of them. It helps convert our initial alignment into a proper alignment with curves pretty much at the click of a button. And then we'll spend a bit of time discussing the culvert panel, how you can add cross drains to your road design. Again, drainage is so important in these flatter situations. And then we'll talk a little bit about creating construction documentation. And for that, we're going to leverage our multi-plot tool. So that's my very quick introduction. I hope everyone, is excited to get in to ask some questions. And with that, I'm going to pass it to our resident webinar expert, Matt. Over to you.
All right, perfect. Thanks, Erin.
Awesome.
Yeah, and I'll dive right in and we'll get underway. So as introduced, we're going to start in the terrain module. So the software is, of course, broken down into modules. And in terrain, we're going to do that front end portion of things where we model our surface, we run Path Explorer, run the hydrology tools. And it's really going to help us visualize what's going on, but most importantly, give us the surface to design with later. So I've opened terrain. I'm going to bring in my DEM tile here. This DEM tile that I have, it's in a TIFF format. The TIFF could be an image or DEM data. So I'm just going to select that it is DEM data. We'll bring that in, and the projection is going to be carried in with it. So there we are. Now down here, I can see I've got about 12 million points. I could probably run with it and be fine, but it is getting handy to that. Well, things might start slowing down compared to if I usually 10 million points seems to be a magic number. So for this, I'm going to thin my data. And as Erin introduced, since it is DEM data, I'm going to use the simplify tool. And here I'm going to just set this to be 0.15. It's a metric example. So I'm removing extra data on planar surfaces and keeping the full resolution on more regular surfaces. So, if I had, say, LAS data, I could do my thinning as well. But for that, I probably wouldn't use this features tool. I would go in here, and if I, say, wanted to have a corridor along that line, I would simplify it along that line, using a corridor for my offset and removing the data I'm not interested outside of it. Now, this set of points that we have here, it's not yet a surface. So we're going to go terrain modeling. We're going to click generate, and we are going to create a tin surface from that. Now, I'm also going to create contours at the same time, and we'll hit OK. And it's pretty quick, but not instantaneous. So we're going to let this thing think as it generates our contours. The actual surface is very quick to generate. The contours take a little bit longer, but not too bad at all. And here, optional step, but it's always nice to see what we're dealing with. I'll click that 3D view so we can get a feel for for what we have on the go. And what we have on the go, as Aaron introduced, is a little different than our typical data set. We've got an example from Northwest Ontario on the Canadian Shield. It's not pancake flat, but these hills are all pretty small. So most of our topography, the hills are, say, 20 meters tall. So yeah, it's a little different than designing a road that's clung to the side of the mountain. Now, that being said, just before I go on with the going through the motions and showing how in the software works, I think it is worth kind of just talking about that, all the benefits of the design in general and what might differ from doing a design in the mountainous region. So the big difference is if you're designing a road in a mountain, it could be that if you plan the road in the wrong spot or start building it the wrong way, you could do something like create a landslide or well, paint yourself into a corner, so to speak, where you've started building it and you've made it so you can't actually get to your destination due to grade constraints or something like that. So in this example, we can probably put that line on the map in a lot of places and still be able to build a reasonable road. What we are going to do, and the benefits here are the same if we're doing it in a mountainous region or not, is we're going to use the software as a tool to help us put the road in the best spot. We're going to use the software as a tool to save us a bunch of planning time and indecisiveness. So with that, design can get kind of be a dirty word where people think it's just spending a bunch of time doodling in CAD or another platform and, well, really losing those benefits. Here we're going to run through a few kilometers in a matter of minutes once we get going. So yeah, should save us time. And I think for me, the biggest thing is just knowing what you're up against. So being able to have that visual assessment of seeing how you're interacting with the surrounding terrain, and then the quantifiable approach where we can see how much dirt we're moving if we use different options. We can use that information to, well, hand it off to builders for construction planning and scheduling. We can make sure our culverts fit are in the right spot, etc. So then once we have this model where we'd like it to be, it's a great tool to set the goalposts for, well, this is what we want our builder to build. We have one client talking to them recently, and, well, they came from a perspective where the reason they came to us was they had a road builder build them an absolutely great road. They could drive fast on it, drive safe, but they didn't need that. They wanted something with a something quick, get in, get out, not waste a bunch of money doing more work than they needed. So it was a tool for them to set goalposts there. And ultimately, as we go through this, well, do we want just a machine trail or do we want a main line? You can tailor your design and plan to meet whatever needs you have and make adjustments as needed. So with that, I'll stop talking and go back to, well, stop talking about some really general stuff and go back to some software stuff. So in this example, I'm going to want to go, and I'm just going to draw a line here. I want to go from here over to, let's shoot for here. Now with that, if we're just looking at the surface, we've got, well, a bunch of low spots. I'm going to want to see what's going on in terms of drainage. So here I'm going to run my streams and ponds tool. Yeah, we'll set this and I'm going to hit OK. And it's going to help us predict where there's streams. So streams will be a line, and then ponds will be a polyline. And with this, we've got, well, these little kind of areas where we expect water to stand. And we also have, well, these bigger features. And these bigger features, in this case, my lakes are these guys here. And I'll just give them a name so it's easier to keep track. Yeah, so we've got that. Now, as I get going here, I may want to have more than just the surface and those features that we've created. So if I want to see maybe an ortho, we can connect to a web map tile service. We can bring that in. And we'll take a moment here while we download that. And here, as that downloads, I'm not downloading it in the full resolution just so we don't have to wait for it to download any longer, but we certainly could. And there we are, and we can see that our lakes are in fact lakes. So let's do our first real design portion of the exercise. And for that, I'm going to use our Path Explorer tool. And as Aaron introduced, we thought about just designing this one by hand, but it really is one of those things that it's easy to become somewhat lazy with that. And it's a lot easier to just click a few buttons than go through and try to figure out manually where this thing should go. So I'm going to use the optimization tools. I'm going to go to my Path Explorer AI dialog, and we're going to begin setting this up. So first thing I'm going to do at the start of my road, this is a forestry example. So my mill is this way. Rather than just having a T intersection, I'm going to force it so it's kind of pointed in that direction to begin with. I'm going to tell the software, well, I want a minimum curve radius of 80 meters. So this is going to be a fairly fast road. Well, it's fairly flat. There's no need of having anything too steep. So I'm going to set my grades to be that, and we'll set our min and max cuts to be 3 meters. Now, as this tool runs, what it's going to be looking at is trying to minimize the amount of dirt that we're removing to build our road. So we've got our cut cost defined in here, fill cost defined in here, and the surfacing cost to shape the road top. You can make those numbers whatever you'd like. What I am going to do here, though, is I'm going to add in some additional costs. So one, this lake area here is a surface, so I'm going to say, well, I don't want to go into the lake. So I'm going to assign a no-go area for my lakes. Then I've got my polylines. So I'm going to add my polylines or my streams, and they're going to have a bit more of a cost associated with them. And we could split this up in a bunch of levels of detail if we want, but I'm going to just say they cost about $3,500 a piece. We'll hit OK. We'll hit OK, and we wait. So again, one of those things that doesn't happen instantaneous, but for what it is figuring out, it is incredibly fast. And it's going to, well, one of the options was I wanted to give me 5 options for possible road locations. So it's found 5 solutions. It's continuing to look for what it thinks are the best 5 solutions to report. And we're going to hang tight. So after a little bit of time here, it's going to say unlikely to improve further. We'll hit cancel, and we'll see the lines that it put on the ground for us. And plugging away. It shouldn't take too much more than a minute and a half or so.
A great opportunity to remind our audience, if you have a question, feel free to type it in the chat. I do see we've got a couple questions there, one of which is this presentation going to be recorded for future use? And the answer is absolutely yes. These webinars do eventually make it up to our YouTube channel. And as a registrant or an attendee, you do receive the link directly to that video recording as soon as it's available. So we send it a little e-blast. And with that, Matt, you've got a
Perfect.
nice message.
Yeah, it says unlikely to improve. So I'm going to hit cancel, and it's going to spit out 5 possible routes that we can, well, are certainly worth pursuing. If we do want to look at these, and I'm going to turn off my ortho here just because it's certainly useful, but it makes it hard to see looking at my screen on your guys' screen. Yeah, so we've got these routes that snake through. Now up at this end, we can see all those different options are right on top of each other. And if we just kind of, well, take a glance at this, where it's put the road, it makes a lot of sense. We're right on the ridge. Where we're off the ridge, we're dealing with the grade constraints that we do have, generally avoiding drainage issues, which we've told it that it costs more. Now, as we get down where the ground's a bit more broken, there's more options for where we can put things. Well, we can see it's going all over the place. And what that says is, well, that there are different ways to tackle this and still be decent, but we can say, well, which one of these different solutions is the best? We can right click by name, and we can see these features. So these Path Explorer features have a number after them, and that number represents the cost given the information we've told it. So out of all these solutions, this guy's the cheapest. If we kind of just look at it critically for a moment, well, yeah, I believe it. We've got some other ones that are taking longer to get similar locations or crossing more rough ground. Now, none of these are absolutely atrocious solutions. So if there's some reason we can't be here, it might be worth exploring one of these other ones. But I'm going to run with this guy. So we're going to hit File, Save As. We're going to save it as Topo. And I'm going to minimize this, and I'm going to switch over to location. So in location, I'm going to create a new location file. I'm going to reference that train file that I've just created. Now, the initial alignment that I use, if I didn't use Path Explorer, I'd probably just start with a single point and I'd click in my road by hand. But we've got that Path Explorer solution, so we are definitely going to use that instead. And here we are. So we've got a couple things worth talking about right off the bat. My cross-section geometry. So the first real design consideration that I'm going to make, I've got my template. So this cross-section template controls my road cross-section geometry. If I want to change the width, I can do that in here. Change my cut slope, fill slope, I can do that in there. I'm happy with my default, so I won't make any edits there. So that can be seen here for our cross-section view. I've got my plan view over here, which is kind of the bird's eye view or map view. If I want to add in that ortho image that we've downloaded, I can right click, click plan, and I can add that image in here. So there we can see the trees and all that good stuff. My view over here that I have displayed is my profile view. So that is showing us, well, kind of a long cross section along the center line of our road. I've got my grades showing here. Now with this, I'm using an exaggerated scale, so it's not actually as steep as it looks here. I'm just stretching it out by a factor of 10, so it's easier to see the highs and the lows. And then my 3D view, I'll hit the zoom to extents button and I can see what I'm dealing with. Now, we've got that. If you're using previous versions, 10 and earlier, it'll take a little bit of just clicking into the options and setting up your corridor so you can see your corridor as you design. So that's kind of an overview of what we're dealing with from an interface standpoint. Now let's turn this line that we have into a proper design and give us even more useful information. So first thing I'm going to do, I'm going to come into Polyline to alignment, and I want to take this and turn it into a series of curves and tangents. So right now that's just a polyline. It's going to be easier to design if we want to move something later with curves. So rather than moving a bunch of vertices, we can move a single IP. And it's also going to help make sure that our road is safe and we can drive on it as fast as we'd like. And this, again, it's not instantaneous, but there we go. So we've got our curves and tangents. Now for my vertical, I'm going to do another optimization here. So I'm going to go in here. I'm going to set this up and I'm going to say, well, I want a vertical alignment that has all my cuts and fills. We have our minimum and maximum grades. I'm going to put that in here. I'll say, well, I want a crest of 3 and a sag of 4. I'll hit add edit. And I'll say, well, at the start of my road, I want to tie in with the existing road. So I'm adding a control point. Next, we'll hit process. I'll reduce this just because it is flat. And we wait, and it's going to, well, figure out our vertical alignment and apply those vertical curves. And with that, we'll get the cheapest solution. We'll get a design time cost estimate. We'll look at our earthworks to see what we're dealing with. So there we are. So I'll zoom in here. We can see, well, through here, we're infill. Makes sense. We're knocking off the top of this hill though. And so as I click along here, I can click anywhere along my alignment and it's going to, well, show me where I'm at for the cross section, showing me where I'm at in the plan view. And we can go to our data table, which is down here, and we can see to build this, we're dealing with about 6,500 cubic meters of cut and fill. And we've got some gravel on our road top, so we're 2,500 cubic meters of gravel. We don't need that. We could have changed our template to not have it. So now, if we want, we can say, well, let's add in our culverts. So at this point, we can look in the 3D view. We can see, well, there's a draw here. We are probably going to want to put a pipe in there to allow the water to vent through. That will go to our culverts panel. We'll click add. And there we are. And so we can go along here. I'm going to add another pipe at this point. So this one being a larger crossing, we'll go in here and I'm going to change that to be, well, let's go with a 1,500, whoops, instead. Now, I'm not going to do this for each and every one of these culverts just because it's a little repetitive. But if we'd like to have a data table similar to this one, but with our culvert information, we can totally come over here and we'll say, well, I want to add in my report points for my culverts. I want to see what station they're at. I want to see my diameter and my length. And there we are. So as we add and change things, we can see what we're dealing with here for that really quick bill of materials. And once we're happy with what we've got, we can go over to our multi-plot editor. And this is where we're going to put together that documentation. So this model that we've created on our computer, and it's really nice for us to know where we should put things. Well, we can take that documentation out to the field and maybe, well, before construction, walk it, make sure that there's nothing that we, no surprises, make sure there's no archaeological sites or anything like that that we need to avoid. Or we can use the documentation to give to our builder. So for this, we can set our page size. Go with that. I'm going to come over here. We'll say, let's go a plan over profile. There we are. We can see that. We can see our plan over profile, plan being that bird's eye view of things. We can add in another chapter with our cross sections. We can control how frequently we're seeing those cross sections. Oops. So here, if I want to see them every 10 meters and anywhere that we've added a pipe, sure, we'll just get more. And there we are. Now with this, we can customize this however you'd like. Now, if I was building this, it's kind of nice to know where your cuts and fills are at. So here my greens are fills, my reds are cuts. This, of course, in the forestry example, this is usually not something that you're sending a surveyor out there to build it within an inch, but the document itself is a nice visual aid to point everyone in the right direction and establish what those kind of goalposts are for things. And then if you kind of want to go in between that full survey control versus the visual aid, we can file, save as, and we can save this out in as a Venza file. And with that, you can open it up on a Venza. And when your builders or you are out there, you can have a little dot follow you around as you're in that plan view and show you exactly where you're at. So with that, I covered the ground I was hoping to cover, and I think we can tackle some of those questions.
Awesome. So your first question, my point cloud has areas with tree elevations instead of ground elevations. Is it possible to shift these areas down to get a tin model with an accurate elevation value?
Yes and no. So there's, short answer is we aren't a point classification tool. So there are different softwares that dedicate themselves exactly to that. Now, with that, if the question is just I have LAS data and it contains both, when we bring in LAS data, we can choose what classified points we're dealing with. Just I'll just be a second here. I'm going to pop open an LAS example to show it. So if it's just that you have an LAS file and it has been classified, well, we can just select we just want ground points. We don't want all the points when we're modeling. If the data hasn't been classified, the best thing to do is classify it in a classification software. But if it's just small areas that you want to manually control, you can draw polygons and trim them out and have that interpolation across the surface. Yeah, so hopefully that solution makes sense. I don't have a good example where I can run through that right on the fly, but let us know if you'd like me to talk more about that outside of the webinar.
Excellent. The next question goes back into Path Explorer AI, which is, are these AI tools applicable to an area where there is thick forestation and hilly terrain?
Yeah, totally. So this one is the hilly terrain. That's our jam. That's our bread and butter. We're a BC-based company, so mountains and hills are part and parcel of day to day. The hilly terrain, or sorry, the tree cover. LiDAR technology, so this is a LiDAR example, is really quite amazing, and it's advanced a lot over the years. Now this is, we'll turn that background on. So this is all heavily vegetated, but we have, this is Northwest Ontario in Canada. Folks are using it all over the world for all kinds of different projects, and with canopy cover that varies from none in a desert to full-on jungle. So it's pretty great. Hopefully that answers the question.
Awesome. The next question talks a little bit more about LiDAR data. This one says, what should the resolution of my point cloud be to have an accurate tin surface?
All right, so that is a little bit of a loaded question for me. So there's no one size fits all. The resolution itself, it comes down to what are you comfortable with? For DEM data and resolution, a lot of our clients are using 1 meter DEM data interchangeably with the raw LIS files. With that, it's worth noting though that the DEM resolution is going to be at the mercy of the original LiDAR data resolution. And with that, the LiDAR data resolution is going to be a little bit varied, depends on all sorts of things. But canopy cover is one of those. So if you have really sparse, a low intensity LiDAR survey and they weren't getting many ground points, the resolution that they're reporting might be all hits, so including everything that hits the canopy, but they might only get a few ground points. So it is somewhat subjective at what exactly ticks the box, but usually you can do a quick visual assessment of it and see what you're dealing with. And for that person asking that question, I can probably give a little bit more tailored answer outside of the webinar and chat about it a bit more if you'd like to reach out.
Excellent. Our next question, you showed thinning of the LiDAR data, Matt. Can you talk about how you can clip the surface itself? So not just thin it, but clip the LiDAR surface.
Yeah, so let's, I'm going to pivot. I'm going to deal with that, some LAS data here. So this will show a little bit of different stuff than what I covered there the first time. So this LAS data is, well, the points are irregularly spaced and they just happen to be wherever we've got a ground hit on this example. Now with this, if I only want LiDAR data or surface over here, we have, well, a few different ways we can tackle that. But the most common are whether we do it as a corridor or we do it as a polygon. So I'm going to just draw in a feature. Actually, I'm bad for that. I just clicked something on my keyboard rather than clicking the buttons on my screen so people can see what I'm doing. So I hit home, new feature. I'm just going to draw in a feature. And this doesn't have to be something that you draw in terrain. It could come from a shape file or KML if you had it as well. So I'm going to just close that. So as is, I have LiDAR data everywhere. If I want to trim it down to just be surface data in this, I can go terrain modeling, simplify. I'm going to remove all points, but I'm going to remove all of those points outside of that polygon. And I'm going to define what polygon I'd like to use. We'll hit OK. We'll hit OK. And now, so I'll hit Control A. Actually, again, I'll try to not hit keyboard shortcuts. I'll right click and select features all. I can see now my LiDAR data is just in that polygon. I don't want that to be modeled. We'll click generate. And so now, instead of having surface data everywhere, I've trimmed that down just to the area that I'd like. And there we are. We can see what we're dealing with. So hopefully that answers the question. Hopefully, yeah, adequately covered it. Yeah, let us know if it didn't.
Okay, let's do one, maybe two more. Your next question is, this one's a little bit of a long one, so I will read it out loud in full. It's going to focus on plan display. It says, we readily use LiDAR to display as a hillshade, sorry everyone, in plan view. And how easy is it to turn the contours on and off in plan view to support our interpretation of the topography?
Yeah, so I don't have a hillshade right here, but I do have a canopy height model. So the premise is going to be the same. At least I think I do. Watch me put my foot in my mouth. So I'm going to add that in as a background. So the hillshade is really just an image. Now it's not going to be available from Google Earth, so we aren't going to click import. We'll click insert, and here I've got that canopy height model. So just it's a TIFF, it's an image. I'll bring that in, and there we are. So I've got this image that's not just an ortho, graphical representation of what's there. So this could be used interchangeably with the hillshade aspect of things. Now I'm going to hit canopy height model, and yeah, so back in this one, I'm just using this because it does overlap with that other one. We can add that other terrain file in as a background, and in this case it's in terrain, but we could do the same in location if we wanted to do it there. So yeah, the trick for those hillshades and other visualizations that you may have on hand as an image is just to add them into their own terrain file as an image, and toggle that on and off as you'd like. For the contour side of things, well, it could be if it's in, and I assume it's in terrain, we could go in here, or sorry, in location, plan options, background, and if we decide that we just don't want to see those topo features, we can toggle the display off for whatever backgrounds we're using. So if we'd like to turn that off but still see our image, there we are, our contours are off. Now the other extension of this is if we'd like to control individual contours, we can I'll just say we don't want to see that one, which yeah, I made it so it's not visible, and then we can turn it back on if we'd like afterwards. And then the other side of I'm going to turn that canopy height model off for a second. The other side of interpolating our contours, contours really are kind of intended to be more of a visual aid than anything else. So that if we're modeling it, it's not looking at the contours, it's looking at the surface that the contours are generated from. If we want to say smooth these out, when we generate the contours, there's options for smoothing and thinning. They're in here as well. So if I want to smooth this out or simplify, we can, and let's just round that out. And so here, those contours are now smoother, or we can simplify them if we want to eliminate extra points and we get something a little more jagged. If we want the contours to follow exactly the triangles underneath them, when we're in here, we turn that off and we generate the contours without thinning or smoothing. So yeah, I gave a long-winded answer there. Hopefully it covers the different nuances of what the could be looking for. And again, if I didn't cover it adequately, let me know and we can arrange a quick call to run through that in more detail.
Okay. Guys, let's tackle one more question here, which is there a manual for this webinar? Which is a really great question. And unfortunately, just given this frequency of our webinars, we unfortunately don't create manuals for them. But a lot of the content that you did see today is available on a different example file, but we do step through that content in our new training course. And we will be sure to share a link to the new training course that we just launched. We'll share that through in the follow-up email that's coming to you all with the recording. There is another 2 or 3 questions sitting in the chat. We will follow up with you folks individually after the webinar. And I just wanted to thank everyone for joining us today, but we're glad you're here with us and look forward to resuming our fall schedule of webinars. They're happening again bi-weekly. We're out of summer mode as of today, and webinars are going to be every 2 weeks on Thursdays. So thank you again for joining us. Thanks, Matt, for tackling the presentation, and we hope to see you all again soon. Bye, everyone.
Thanks, everyone.